Hello, everyone. Thank you for coming. Today is actually going to be a tag teaming type situation where two people are going to be on stage. My name is Diogo Mo. I'm the co-founder and executive chairman of Anchorage Digital, which is a very fancy title that I chose for myself. So I highly recommend you guys choosing such a fancy title for yourselves. And we have Gonc, Pereira, which is a member of technical staff. He asked me to say publicly that he's the best engineer of Anchorage. So that's how I'm going to introduce him. So today, the talk title that I chose for you guys is, Can we turn language into a financial product? And hopefully that has enough mystique for me to capture attention for the rest of the 15 minutes that I'm going to speak, and then I'm going to invite Gonçalo. The goal here is that I'm going to try to inspire you, and he's going to try to bore you to death. That's going to be the split. That's how we're going to try to do this. So let's see if either of us is actually going to accomplish the mission. Okay. We're going to start with our beautiful faces. This is what we look like, in case you weren't able to see. Let me tell you why I'm on stage today, and a little bit of the story that got us to Anchorage Digital. So one of the cool things about me is that even though I was born in the US, I actually came back to Portugal when I was 3 years old. So I'm really the product of Portuguese education. And the reason why I have a cool hat over there is because I did all my education in Portugal and ended up doing PhD at Instituto Superior Técnico in Lisbon. And so all of my academic career was in Portugal. Until I was 24 years old, I was in Portugal. And when I was 24, something really cool happened during the PhD, which is I went to work for a company called Square, now Block. This is an early stage company. When I joined, I was employee 40. I went to work on the security of this company. I entered when they were a Series A company, pretty small, and when I left, there were thousands of people, and they were worth $100 billion on the public market cap. And so startup to IPO, the whole journey. This company had been started by Jack Dorsey, which was the CEO of Twitter, which had been fired from Twitter and really had the chip on his shoulder, so he really wanted to succeed again. And he's still one of the few people in the world that has been the CEO of two publicly traded companies at the same time. At one point, he was CEO of Twitter again because he was brought back, and he was CEO of Square. And at that point, Twitter was like $50-something billion, and Square was $70-something billion. So, something to be proud of. I learned a lot from Jack, learned a lot for 4 years at Square, working on the security team, engineering, cryptography, systems, et cetera. And then in 2015, I decided to go work on something that I could actually sell to people. Because turns out Square was a payments company that sold to consumers. So consumers don't really care about security. You don't talk about security. You don't go to a consumer and say, how do you like the fact that your credit cards are not being stolen? That's not a conversation that goes well. However, institutions love security. And I really wanted to build a product that worked in security and that I could sell. And thus, I went to a company called Docker. Since this is a development conference, I don't have to explain what this thing is. It's extremely hard to explain what this thing is for people that are not technical. I'm trying these. It's like a container, but in the virtual world, and you sort of swap it around, and it runs on all the clouds. It's extremely awkward conversation, and so I'm glad I don't have to have it. So I led security at this company, Docker, for 3 years. It became a $3 billion company. It runs on every single cloud server on the internet. Most of you probably use it. It's a really cool piece of tech. And one of my main responsibilities and one of the things that I'm most proud of is how do you actually make a container safe when it actually doesn't have access to a lot of the virtualization techniques that you have for virtual machines, and how do you make sure that you're running on user land and you make sure that a hacker can't escape this container and can't hack actually the host, even though these things are playing against you. So that was pretty fun. And then I went and started my own company, which I highly recommend all of you do. Not just because you can choose your fancy title, you can do that, but it's really, I think, the final direction that you should take. You create wealth for yourself while creating wealth for the world and your employees. And it's really fun, and it's extremely stressful and extremely rewarding. So I highly recommend you doing this one day. Anchorage is the first and still only federal chartered bank in the United States. What we do is custody, staking, all sorts of businesses for cryptocurrencies. But we only work with institutions. We don't like retail. We don't like people. We just like institutions. They're much better to deal with. You ask them what they want, they tell you what they want, and then they pay you for it. And consumers, you ask them what they want, they tell you something, and then God knows what they're going to do. So I hate revealed preference. I love stated preference, and stated preference is much, much easier when you're working with institutions that are rational, have budgets, and pay a lot of money for something that is actually securing their systems. That's what Anchorage does. I'll talk a little bit more about it. Then I'm also the chairman of Near. Near is a blockchain. It's fun. and I'm also a general partner at Han. Han is a $1.5 billion, $500 million early stage fund and $1 billion growth stage fund. And the only thing that we do is we invest in digital assets. So I put checks into companies and help them grow. So I've built stuff, I help people grow, and I've actually founded stuff. That's sort of like, in a nutshell, the reason why I'm on stage. This is one of the proudest moments of this company, was the fact that we are chartered in the United States the same way that JP Morgan Chase is. We have a federal charter, the OCC is our main regulator. So 5 years ago, when everybody was saying that crypto was unregulated and it was just for scams and people trying to pull rug pulls, we were going the direction of actually getting a bank, actually being regulated, actually bridging traditional finance and bringing TradFi, New York, into crypto in a regulated manner. So something extremely proud. And there's lots of people from Anchorage in the audience, so they should be extremely proud because they built it. I'm just the one that is actually speaking on stage. Okay, so the talk today. First, let me start with a little bit of context on what we're calling the Web3 stack. It turns out that when we first built the internet, we made a very crucial mistake. I call it the capital sin of the internet, which is we forgot how to monetize it. We did not build money into the stack of the internet. There's no way, if you think about it, outside of crypto, for you to natively move funds back and forth. And in fact, that led us to create all sorts of crazy stuff. Credit cards on the internet are horrible. Horrible experience. They do not work. They do not actually, weren't made for this. So we've tried all sorts of hacks with tokenization to actually make it work. And even worse, we actually were pushed towards the direction of ads. The reason why ads work so well and are so ubiquitous is because no business on the internet until 2010 could actually charge for their products very easily because there's no native way to pay. If there's no native way to pay, what are you going to do? You're going to use ads. And if you're using ads, what are you going to do? You're going to collect as much data on your users as you can so you can monetize it as much as you can. And this creates a vicious circle of data gathering by companies and exploitation of ads, and on and on and on it goes until you have the modern day bullshit of all of these ads out there and the internet not actually working very well. So what happened in our space is that there was something called Bitcoin that was created because of the 2008 crisis in which banks were being bailed out. And so the banks make money when times are good, and then us, the taxpayers, pay for the banks not to lose money when the times are bad. That was horrible. There was this guy or girl or gal or group of people that we don't know who it is called Satoshi Nakamoto that created the first truly decentralized peer-to-peer system. And then in crypto, we've evolved this into a full stack that goes anywhere from base layer infrastructure that actually is very overlapping with traditional internet, but it has a couple of interesting new things like mining and nodes and tokens and storage, but it actually builds upon it, uses tokens, alignment of incentive, and consensus and new permissional models, allows you to run arbitrary code on these permissionless smart contracts, and just allows you to build, to a certain extent, a new internet on top of the primitives that we had before. Why do we need it? Because we need to escape ads. We need to escape the lack of modernization. We need to escape the players like Facebook and Google that have a chokehold on the current internet. If you want to search, you only go to one place. If you want to do social media, you really only go to a couple of places. That is not how the internet was supposed to be. We failed. So we're trying to build it again. So this is the new internet stack. And what I want to talk to you about is within the framework of the adjacent possible. There's a famous biologist that came up with the adjacent possible, in which what he stated is that the innovation and evolution actually occur by exploring possibilities that are immediately accessible from the current state. And what that means is that you just don't go from, a fish to a monkey jumping on trees. There's a series of evolutions where fish first need to be able to breathe out of the water. They actually need to start walking in land, spending some time in land, and then eventually they evolve into mammals, into human beings. You cannot jump steps. You have to go to adjacent possible. So it's sort of the framework that I'm going to talk to you about and how I'm going to get to generative finance. And in particular, I think we can debate this, but I'm going to tell you today that it is a fact that cryptocurrencies and crypto in general has made money move at the speed of data. We didn't have that before. Money is now accessible to anyone on the internet. That was not there before. Money is programmable by developers. That was definitely not there before. And finally, money is transparent and auditable. That was also not part of the primitives that we've had with the traditional financial industry. Assets are the next step. Assets right now do not move at the speed of data. cannot do real estate at the speed of data, not even equities for European or American equities for European. They're not accessible to anyone in South America. They're not accessible to anyone in Africa. They're not programmable by developers. They're like chokehold behind a few APIs of a few companies, and they're not transparent and auditable. In fact, in many cases, there's more votes than number of shares on companies on the NASDAQ. They don't know how, but there's 106% of votes when there's only 100% of shares. So that's the kind of state that we're in right now. This can help. So let me start by talking a little bit about money. In crypto, we've created this concept of stablecoins. Stablecoins are essentially pegged cryptocurrencies for which there is $1 in a bank account that is tied to $1 on chain. So the trick is very simple. You put $1 in a bank account, or a T-bill in this case, which is treasury liability from the Fed that generates yield, and on chain what you have is a dollar representation that now moves under 1 second. It can actually be transferred between you and I for under a fraction of a cent. It actually is globally available. It doesn't matter if you're in Portugal or if you're in Argentina. You can download an app on your phone right now and access it. And then finally, it's permissionless. Right now, in 15 minutes, you can pull up your laptop and build an application that takes money, an application that has the equivalent of a bank account. That was never possible until stablecoins came along. And so this is a major shift in how we actually move money on the internet. And this is the thing that gives us all the characteristics that I told you about. There's lots of layers. The three major ones are issuers. There's people that issue these cryptocurrencies. Tether is one big one. We have Circle. We have Athena. On top of that, we have companies that move them around. We have BVNK, we have Bridge, and then on top of that, you actually have applications which are consumer applications. Think about somebody trying to build, global Venmo or a peer-to-peer money sending app, but instead of using traditional rails, building stablecoin rails. This is happening right now. These companies are growing extremely fast, and they're actually rebuilding traditional rails with this better primitive, which is stablecoins. However, I think the skeptical folks in the audience actually are saying, okay, but stablecoins and the things that are being rebuilt basically look like the things that were there before. I already have a bank account. I can already send money to my friends, even though, candidly, MBWay sucks, but whatever. I can send money until $900, and then I have to go to my bank account, but it doesn't work on weekends. So I can argue that working is with major quotes. However, embedded finance has been the neobank approach to saying, no. Why can't we do this from the current system? Why can't we make the current system better by doing, faster settlement that hides away how money moves underneath, by actually doing embedded loans where people can have loans, by doing purchasing online with Stripe. Stripe makes it so easy to get money. Stripe works with the traditional financial world. So why is this actually not a better solution? Why do we need to go to a total alternative system like crypto and actually build something that is just not part of the traditional financial world at all for this to work? Well, it turns out that if you look at the definition of embedded financing, embedded finance actually reduces the need for consumer bank interactions. That is true. Both technologies do. They use code to replace interactions with bank. That's also true. Businesses embed financial systems to increase the consumer retention and create new revenue streams. And this obviously unlocks enormous efficiencies for companies and their customers while increasing the bank revenue. This is the main problem that we stand in right now, is if you try to build this from within the traditional framework, you cannot get rid of the intermediaries. And if you look at the actual amount of revenue that these banks are making right now, half of the revenue that is being made by banks is now through these partnerships. They literally do nothing except sit in the middle between the fintechs that are giving you the service and the banking system, and they make 50% of the revenue from this. This is the thing that crypto actually gets out of the way. Crypto enables better embedded banking and financing because it actually removes the banks from the equation. There are no gatekeepers. You're a developer, you can build today in crypto. Nobody can stop you. There's better economics for applications because there's one less intermediary. Somebody is not charging for the transaction. That means more margin for you. There's faster iteration and easier composability because code is open source. Anybody can use it. And then finally, you are serving the global market from day one. This is extremely important. You create a company using stablecoins or crypto in Portugal, and you can serve South America, and you can serve Africa. There is no difference. So I hope I've convinced you that crypto enables better embedded financing and that these rails are not just an equivalent to the traditional attempts at making the current rails better. They can do something the current rails simply cannot do. Now let's talk a little bit about assets. What's up with assets? Well, when you have assets off-chain, they have a bunch of problems. And when you put them on-chain, you immediately inherit a set of characteristics that are extremely interesting. First and foremost, if you tokenize any asset, say gold or property or art or whatever, you inherit every single one of these characteristics. Because what tokenization in crypto means is you just slap code around it in an API. And so it allows fractional ownership from any asset on day one. It allows instant real-time tracking of ownership. You know who belongs to what on a second basis. You have liquidity. Again, the global access to crypto in the markets means that now real estate that is tokenized in Dubai can now be accessed by an American investor, which was not possible until now. You have higher capital efficiency because you actually can have collateral that earns yield for you. And then finally, you have instant finality. So all of these characteristics are inherited by any asset that gets tokenized on chain. And that is one of the reasons why it's the next step after money and after stablecoins. And you can think of it as a logical next step. In fact, stablecoins are tokenized dollars. That's what they are. And so we're coming for all the other assets. Finally, I want to talk to you about tokens. These tokens, as I mentioned, they're code. They're not a paper. You can actually engage and interact with them and compose them. And the reason why this is so important finally comes to the beginning of our talk, and the reason why I want to talk to you about this is because if tokens are code, and LLMs now turn language into code, we know that these tokens and these smart contracts can turn code into financial products, because that's what they are. If you connect the first and the second one, now what you have is you have a possibility of turning, with LLMs, language into fully featured financial products. What does that look like? I mean, this is what generative finance is. You can start with a prompt at the most basic version. The prompt gives you language, so it gives you a description of whatever instrument that you decided to create. From an instrument description, we already know how to turn it into code. You guys probably are using it on a day-to-day basis, all of these tools. And then from code, on-chain, you can now deploy into a product in which any user in the world, globally accessible, instantly can click and deposit and interact with. This is the beauty of what's coming next. Generative finance. Products that are created and tailored just for you. Instead of an institution selling you the product that they have, they can actually create a product that you want. So this is part of the adjacent possible right now, and I'm extremely excited about this direction. I'm investing in these companies, and at Anchorage, we're definitely building the things that are necessary for this to happen. So how do we get there? And it's easy to talk about the vision, harder to talk about the implementation. So for the hard stuff, there you go. Welcome, Gonzalo.
Thank you. Thank you very much, Diogo. Thank you. So as Diogo presented me, my name is Gonçalo Pereira, and I'm here to bother you to death, right, with not so fun part of generative finance, of how to get to this future or to make this a reality, right? But how do we get there? So recall first that Diogo basically walked us through money and assets, right? And he mentioned that for money, we do have a concept already, stablecoins. Same thing for assets, tokens. And he even made the statement that these two are pretty much the same thing, right? They are versions on a blockchain of an asset that we have nowadays, right? Fiat, bonds, ETFs, whatever, even real assets, commodities, and whatever. But the thing is, in order for this to become an actual reality, we do have to have these representations of financial assets, of assets on chain, but these won't happen just because, right? Originally, the blockchain started as an initiative from individuals, right, to solve a problem, and that hasn't been lost. But the fact is, we do need institutions on board, otherwise that reality won't happen. It won't come true, okay? So really here, the key point is that generative finance is hinged on having institutions on the blockchain, right? Otherwise, how would you trust a stablecoin that is issued by someone that you cannot trust, right? That you cannot have confidence on. The same thing for assets. How would you buy the token of some property and somewhere, some other place, if you do not trust the institution that will actually honor that tokenized version of that asset, right? So effectively, yes, institutions are indeed necessary, and I can tell you, otherwise we wouldn't be here, that Anchorage mission is exactly that, as Diogo mentioned in the beginning, right? And so we want to talk a bit about the challenges and without beating too much around the bush, how Anchorage is actually facilitating this reality or making it true. But let's first take a step backwards, focus on the money part, the stablecoins, and more specifically on the issuance, right? The issuance is the process by which the stablecoin actually appears on chain, right? And so as an issuer, really what you end up creating is a representation of your stablecoin on the blockchain, but how exactly is the stablecoin created on chain? They are created, for example, on Ethereum and other EVM compatible chains with a concept called smart contracts, which is basically code, as Diogo mentioned it. And I brought here like just a subset, a small subset of what normally, how normally a stablecoin is like instantiated on chain. And it's basically a piece of code with a bunch of functions, these ones being the four most important ones. We have transfer, of course, like to send funds around. You specify the destination wallet. It sends from your wallet to the destination wallet. Balance off for you to know what exactly is your current balance. And then we have two odd ones, I would say, mint and burn. These are the ones you can already tell that are related with the issuance process, right? Mint to create new units of the stablecoin, burn to burn those units of the stablecoin. But how exactly is the issuer like minting and burning these stablecoins, right? It's with a process called issuance and redemption. Walking you guys very fast through the two flows. On issuance, the customer has fiat, deposits fiat, the issuer mints new units of the stablecoin and deposits those on-chain to the customer's wallet. And the redemption is basically the opposite, right? You deposit back to the issuer's wallet or the issuer's ownership units of that stablecoin. That transfer is confirmed, and the burn is called so that those stablecoin units stop circulating, and then we redeem back the fiat back to the owner of the stablecoin. And so really, this process has its challenges. An institution nowadays wanting to issue their own stablecoin, and there's multiple reasons for one institution to do so, is faced with a number of challenges which we at Anchorage identify as four main groups. First, security and scale. You need, as an institution, not only to securely hold your assets, right, but also protect all your users against fraud and misuse of that asset. And you actually have to serve millions, not only within the constraints of your platform, but also on the publicly available blockchain, right? That has a number of additional non-intuitive security challenges, namely, you have to audit your code because your code is deployed once, never is changed, and so forth. But aside from the obvious security and scale issues, there's also a challenge of legal and compliance, as you operate under multiple jurisdictions, you have to operate under a clear framework. Otherwise, you might find issues with governments and other institutions and with regulatory bodies. And then you have, of course, to have access to the traditional financial infrastructure as you hold fiat, as you hold USD, euros, whatever, in order to facilitate the issuance and redemption process. And obviously, we do need to integrate with the blockchains, right? The multiple blockchains that we want to operate. But how or why exactly do we need to be present on multiple blockchains? Can't we just select one and leave it there? No, because you, as a issuer of a stablecoin, you are interested in having your stablecoin be present on the biggest number of blockchains, because it will be a key essential requirement in order to have widespread adoption of your stablecoin. And so I wanted to give you a bit of some insight into those challenges, right? And one of them, it starts with, well, by the way, I'm going to talk only about the last one, because otherwise we would be here the entire rest of this afternoon. So when integrating with the blockchain, of course, like, blockchain integration is one challenge, but what do I mean exactly by the challenge of blockchain integration? Well, first, you do have to integrate with the blockchain, right? The blockchain is a distributed network of computers, like, working together. And how exactly do you interface with that blockchain? It's through APIs with software that the developers of those blockchains provide to you. And so you can already see, right, like, where I'm going. As you integrate with a lot of blockchains, you are faced with multiple APIs. I can tell you that they will be different from each other. And not only APIs, but also different ways of working, right? Different underlying assumptions and rules of how exactly each function within the blockchain works. Sure, this can be abstracted, and that's part of the challenge of these issuers. But the problem here, in addition to this mess of different APIs and different assumptions, is that a lot of these blockchain projects have issues with their release management process. They will break stuff on you, even in production, like send updates to the blockchain, breaking your integration without telling you anything. So yeah, it's a bit of a mess, really. It's a bit of a mess. You are constantly putting out fires left and right on your integrations. And in addition to supporting each and every single blockchain that you have to operate on individually, you also have to concern yourself with how the interoperability across the different chains work, right? Because you will want your stablecoin to move around, to go from blockchain A to B to C. And so you have to make sure that there's a bridging infrastructure in order to move that around. But also, you have to make your operations support cross blockchain, for example, issuance on one, redemption on another, right? You can't simply operate within the fixed bounds of one. You can't expect someone that asks you to issue a number of units of a stablecoin to do so on one chain and redeem on the same chain, right? Because the idea of a stablecoin is to move around constantly, right? That's pretty much the goal here. But here, how exactly do we at Anchorage end up like solving this? Well, I think you were all looking or expecting this, but basically, like, we have an area where I do work every day, where we have pretty much components where we translate the specificities of each blockchain into some language, some API, where then we can expose all those blockchains in a blockchain agnostic way or generalized way to all our products, like custody, trading, in this case, issuance of new stablecoins, right? There's a lot of challenges here, like these APIs, the way that blockchains work, the nature of how block processing is exactly performed. Like, there's a lot of things to know here and a lot of technical challenges. But in order to know more, I challenge you to join us at Anchorage. But a problem related with this blockchain integration, it's not only that you are integrating with the blockchain, not only you are calling these APIs, but you are doing so for a specific purpose, right? You want to issue and redeem your stablecoin. You want to provide that stablecoin for users to do all sorts of stuff and enable all sorts of use cases. And in that there's one follow-up to blockchain integration, which is a balance tracking and reconciliation of what's happening on chain. And again, we have some challenges here. By the way, like Anchorage already supports more than 55 blockchains within it, like 700 assets. This includes, of course, stablecoins. But as I was saying on balance tracking, if you stop a bit to consider, okay, so we have to implement or integrate with multiple blockchains. We are doing so, and we have to basically like reconcile those all within our system. But there's another reality that we have to reconcile with what's happening on chain. And basically, that's what happens on your side, your platform, right? As your customers use your products, call your APIs or your internal APIs, you also have to not only honor what they're asking you to do, their actions, their intentions, but you also have to do it on the blockchain and vice versa, right? You have to, for example, always accept deposits. You have to constantly monitor the blockchain. And so here, really, like, on balance tracking, and we can generalize balance tracking as a problem of state reconciliation, it's really about reconciling two sources of truth, right? The world is going in parallel in multiple fronts, and we have to make some sense of it so that then we either allow our clients to do certain actions or not. But let me give you an example, right? Nothing like an example. First, blockchains are immutable. People do say that, and they are, but with a small asterisk, right? There's a thing called finality on blockchains, which is the amount of time that passes from a transaction being included on a blockchain until you can actually consider it like final. It won't be reverted, right? It will be immutable. And so the problem with this, there's multiple implementations of finality, sorry. But really, like, how exactly is finality a problem, and how exactly can these impact our operations? Consider this example. Imagine that you detect that a certain transfer transaction is pushed to the blockchain, is broadcast, and that normally goes into the mempool, a temporary pool where it's waiting in order to be included in a block. You do find it in a block sometime after, block X, let's say. But then there's an event which we call a reorg. It's basically like a state change of the blockchain. It undoes a number of blocks, a number of transactions. And you have to reconcile this with your internal state, right? Because that transfer transaction might actually be canceled or replaced after the fact. So here, like, why am I talking about this? Because you, as an issuer, if you, somewhere in the middle of these two highlighted points, if you actually accept the redemption of a stablecoin, you might be found without neither fiat nor the stablecoin, right? And then there's an operational cost to that, right? So how exactly do we solve this challenge? It's basically like grossly abstracting the actual problem. It's basically a function of time. You have to wait a bit of time until you actually can consider that, depending on the blockchain, true, like final, that transaction, acceptable. And so how do we end up solving this at Anchorage? It's basically like the other architecture that we have seen before for blockchain integrations, where everything converges into a common abstraction. And here, we didn't invent it too much. We went with something that exists already, right? Double entry accounting, double entry bookkeeping. And so by converting what's happening on chain, for example, imagine someone deposits funds into your custody. You pretty much code that as a move of funds between two accounts, right? And then by ingesting that into a unified ledger, you can make sense of what's happening, right? As a user is making a request, you have to look into your unified view of the world, everything, all blockchains, and your internal state and decide if you can honor the request of that user, right? I want to redeem a number of, I want to redeem a deposit of stablecoins. Yes, sure, you want to redeem, but let's wait a bit because you did so on blockchain X, and blockchain, in order to honor something on blockchain X, I have to wait 10 minutes, 30 minutes, for example, on Bitcoin. Maybe expect the block to be finalized, for example, on Ethereum, given how the consensus algorithm works. And so here, of course, I'm abstracting a bit the complexity, but you can already see, like, this is an asynchronous process. There's a lot of things that can happen, but it's basically the modeling a problem with a risk-based approach, right? Either we risk losing assets and having some operational cost, or we lose some experience on the client side in terms of latency, added latency, right? There's no like silver bullet for this, but we do try to make our best, right? But okay, so these are some of the challenges on the issuance process, more specifically with the blockchain integration. But how exactly do we make this reality? Let me go back to what I started with, right? In order to have a future of generative finance, yes, we do need money and assets, right? We do need stablecoins and tokenizations, versions of those that we can actually trust with strong institutions backing them, so that we do get to generative finance, and it's a very exciting future. I do wait anxiously for that to become a reality, but we do need institutions in the mix, right? Otherwise, with those, we won't have the confidence to actually build products, build solutions that will actually solve people's problems, right? And that's about it. That's what I wanted to leave with you. I do have, I did mention a number of other challenges, and there is a lot of things happening on Anchorage in order to solve these challenges. Diogo mentioned one. We are the first federally chartered crypto bank in the United States. That, again, goes for the legal and compliance. But we do work in the number of the other four main problem categories. And if you do, if you also want to work on those and improve, make the future a reality, do join us. Do stop by our booth. It's like in the corner of the sponsor area. And yeah. Oh, I think I went a bit. Yes. Diogo, do you want to?
Sure. I must.
Hello. Thank you very much for the talk. I have a question for you. So
for me?
Yeah. You're talking about the challenges with a number of blockchains that the APIs are broken in production and so on. Is there any initiative like in traditional finance, we have Swift SEPA that connects banks. Do we have any kind of open specification for any blockchain to implement, like, and that any blockchain should support, like, to simplify these transactions at least? Or no?
It's called the blockchain.
Yeah.
In some way, but we have lots of blockchains. Can we have a smaller specification? Is there any idea?
I mean, I think the right way to think about it is different blockchains are like PIX and SEPA and Swift. There's no others meta specification that specifies how they work. So that's the level of abstraction you should be thinking about it. The right level of abstraction here is like, you want to trade with SEPA, it's the blockchain. And the blockchain is public and is auditable and everybody's on the same footing and nobody has an advantage over. And so you can build something like anybody else can build something. There's no acceptance. There's no somebody allowing you, giving you an API key. You can't just participate, which actually makes it easier because you get to see the developers. It's harder because they're not like institutional participants that are giving you like tons of heads up. Hey, we're going to get 3 months. These things are going to like be coordinated. In many cases, it happens. But for the smaller blockchains, these are just not professional enterprises that care about like all of the participants. They're just shipping code. They ship it to GitHub. They push it to production, and they're like, okay, hopefully everybody else has seen this because it's public, and so they can actually update. Which, by the way, has a downside, which is shit breaks. But it has an upside, which is moves much, much, much faster. Which for engineers, you want to move fast. And so I think one thing that Gonçalo, it is hard. We do build into it lots of redundancies on our side, so our clients don't have to deal with it, right? So our clients don't have to deal with like the crazy like edge cases. And there's crazy edge cases. And so you have to build amazing UX, amazing user experience, especially if you think about money. Think about sending $100 million, which our clients regularly do through our platform, and not knowing if the money is here or it's there. Literally, for that period of like 5 minutes, the money is neither here or there. It's like, where's my money? It's $100 million. And we have like 70 billion, right? And so that is like triggering. And so you have to build amazing UX. It really goes anywhere from like the experience of like the queues of like, is this in progress? Is this expected? All the way to like the hardcore custody and blockchain integration implementation of like, do you do retries? How do you do retries? Some blockchains don't allow you to do retries because they actually have nonces. So these transactions actually can't be replayed. So you have to go back to the users like, sorry, you're going to have to try again. And that's a horrible experience. So how do you mitigate these things?
And I think it also refers to, or goes back to, which requirements are you solving for? Because not all blockchains solve exactly for the same use case, right? And you can't really solve all use cases, although some blockchains do try to be like a bit widespread, firing like in all directions. But really, like, as you build for certain requirements, you have to relax on others, right? And as we like investigate exactly how each blockchain works, we do find those. Like, for example, on Ethereum, clearly the prioritization is on decentralization, as in, like, you have 1 million validators currently operating on the network, where then when you compare with, like, some brand new project that, like, promises sub-second per block production, you have, like, 100 or 150 validators, right? So really, like, it's always a trade-off, right? Within engineering, it's always a trade-off. And I would think that, yeah, the answer for that question is really like, what exactly do you want from the blockchain? And so, yeah, it kind of ends up like, you kind of end up operating on one or another.
If you want a very fast perps trading, like sub-millisecond, then you have one server, and you still call it decentralized. So that one is a good one. I don't know how they did it, but that is a great marketing play right there.
Exactly.
Other questions?
I have one more question to that. So, but crypto at the moment is still like kind of in periods of hot and cold kind of. You have sometimes a huge spike of people trading, and the other times it's like, especially when the crypto goes up, everyone starts trading. And if you don't have many validators, how do you deal with that and all of the things that you sometimes cannot retry the transactions?
So, let me just point out one thing, which is, Bitcoin has never gone down. 15 years into it. We have built a distributed system that has never gone down by metrics that we can like measure, like latency. Obviously, like there's some sense in which there's been many times where it's been lagged, it's been difficult to get blocks in, it's been expensive to get blocks in, but it hasn't gone down. You can't, there has never been a moment in Bitcoin's history where you try to interact with the blockchain to see if you have assets there, and you just can't. And so that is extremely impressive. Ethereum has done extremely impressive technical implementations too. And there's also not been like, I don't think any moments in which Ethereum has been truly like offline and unavailable. To a certain extent, it's been degraded because lots of excitement, and you have obviously gas and transaction fees spike, and so you don't have enough money to include your transactions, but somebody does. Somebody has enough money to kind of like participate. And so these are very complex decentralized systems and distributed systems that have been built for high availability in many cases. And when you're on this set of highly decentralized cryptocurrencies like Ethereum and Bitcoin, you actually, as a company, you always have enough validators. You have to deal with edge cases and market congestion, but you always have stuff that you can do and like ameliorate, and you can have degradation of experience. When you're working on Solana, Solana has been already gone down like 6 times, right? And so It's a different set of trade-offs. They're getting better. They're decentralizing over time. But there have been periods where the blockchain literally does not work. And so that's a different mode of operation. So the answer is not one answer, because all these systems have different trade-offs, and all of them have optimized for different things, like Gonçalo is saying. So you just have to treat them differently. It's like SEPA does not have the same failure mode as PIX, does not have the same failure mode as SWIFT, does not have the same failure mode as, I don't know, Fedwire. So all of these things are different systems, even though SWIFT is a message passing protocol and not actually like settlement, but you get what I mean.
Not sure if you...
Okay. Hello, guys. So first of all, thanks for the presentation. Quite inspiring. I already see myself like coding because...
Were you bored, though?
Yeah. Actually, yeah. That's
good.
No.
Great work. We did it.
That's the deal. I mean, the
Inspiring
deal
and
is
boring.
done, actually. No, but I mean, just joke aside, I mean, I was listening to Diogo, and you just mentioned something like really interesting, like from the language to the financial product. I mean, you made a shortcut. And after when Gonçalo started actually to get back to the reality, which is true as well, I mean, at one sense, it's not so easy like we could expect. So my first question is like, is it really today a reality or potentially the future? And second point, from second question, you told guys about crypto blockchain, which usually an ecosystem which is like not really compatible, or I would not say against, but really like going out from the traditional banking. But you guys, you have this talk about, yes, we do crypto blockchain, but we need institution behind, you know. So I'm just curious about this link and actually why you think about that, because usually when you have like a conference about crypto blockchain, we are exiting from that traditional model, you know.
Yeah, totally. So let me tackle the last one first, which is blockchain is permissionless. And there's nothing that I can do or Anchorage can do to stop it and stop that fact. Anchorage will never get a moat and will be able to like lift the walls and drawbridge such that you can come and build a competitor. That's the ethos of crypto, is the permissionless nature of it. This said, you still need institutions because all of the money in the world is not in crypto. All the money of the world is outside of crypto. You have to go get it. And the way to get it is have the institutions that have it funnel it into crypto. That's why we say you need institutions, because the money is outside of crypto, is not within crypto. And there's nothing that I can do that to stop people from participating in the future. So if you see it, it's like by bringing institutions to participate in crypto, you're actually getting them in an open system that then they can't lock themselves into, like they've done now. So the difference of the future state of finance and the current state of finance is that the current set of players can stop you from opening an account. You can't move money, euros, in the traditional sense without an account. They do KYC, they're gonna like run you through this, they can actually stop you. And in fact, in the United States, they've stopped crypto companies from opening bank accounts. They've stopped gun manufacturers from opening bank accounts. They stopped lots of companies that they think are unsavory businesses, even though they're totally legal, from opening bank accounts. So they can. With crypto, they can't. That's a total different set of circumstances and worlds. And so the institutions should come to crypto. We need institutions in crypto. We need to bring the money from New York to the blockchain. And then when it's on the blockchain, everybody can participate with it. And that feeds into the second part of the question, which is, what's missing? Well, number one, there's very few assets still on chain. RWAs are $30 billion of issuance. Stablecoins are 300. By the way, $300 billion is extremely impressive. Stablecoins right now are the 12th largest holder of T-bills in the world. They're bigger than the country of Germany. They're bigger than the country of Saudi Arabia. So they own more debt of the United States than all of these countries, and they're growing vertically like this. Within the next 12 months, they're going to be top 10, and maybe soon, top 1. Like they will hold more T-bills than Japan, than China, which is extremely impressive. These things did not exist 5 years ago. But we only have $30 billion of RWAs, of like private credits, of all of these other things on chain. And on the LLM side, LLMs, and you all know about hallucinations, and they just can't be trusted for something that is indelible, that is a smart contract on chain that has all of your money. You can't just run it through ChatGPT and give me the code and then willy-nilly click one button and deploy it. No. It takes auditing, security, all of these things. You know, we're improving. There's AIs that do security, there's AIs that do bug vulnerability finding, fixing. All these things are being worked on, but they're not reliable enough for you to truly go from language, I just want like to hedge my personal Anchorage position, to code that I can trust to one-click deploy to then put my money on it. I wouldn't. You shouldn't either. But these two things are converging really fast.
Yeah.
And so that's why it's so exciting.
Yeah, and there's already like a lot of solutions to interact. Like it's basically a different way to interact with each blockchain individually, right? There's already LLMs, like MCP servers, right, that allow you to interact with Ethereum, with Bitcoin, whatever, multiple solutions, both by individuals and companies. So you can already do some things, right? But again, the key question is, would you put your hard-earned money on it, right? That's the key question. I would say not. I wouldn't
Not yet.
as well.
Let's check back in 12 months. Do we have stealth time, or are we out of time? I don't know if we're out of time.
Yeah, I guess maybe.
Well, continue asking questions until they kick us out. Are we out of time? No?
No.
Cool. Next question. There's a question over here.
Thank you. Maybe a bit philosophical, but I want to get your point on this. If you want to get the institutions on board, I think this fact of being able to not open an account so that the institution or the banks can force you not to open an account, that feels to me like a feature, not a bug. So how, if you can't raise walls for the blockchain, how can you woo the institutions, given that it might be against their interest to have this free for all? Basically.
So it's not either, right? It's both. So the institutions, like Anchorage, we reject clients all the time. We should have the right as a private company to only do. We chose only to do institutional business. Nobody should be able to force me to do retail, and I shouldn't be forced to accept all institutions, which we don't. Lots of institutions don't make the cut. We have very high standards for KYC and compliance. So Anchorage should and does have a bar for clients, and we reject certain clients. However, the blockchain can't. And that is the right way to build things, is Anchorage gets to make individual risk-based decisions based on our bank charter, in our reputation, in our business, and other people can build on the blockchain to make different decisions than we do. What we can't have is the platform, the system itself, SWIFT, controlled by a set of entities that all together say, these are the rules, and I only allow these countries and not these countries. It's a totally different thing. The network is open, the companies are closed.
Follow-up. So sure, and I connect back to the point, or to that slide where you showed that the banks are basically making a lot of money from this, and they're not necessarily adding value. And
by the way, we're a bank, and I want to make a lot of money,
exactly.
so let's be clear.
So is that not the value exactly that you're bringing to the table, and the banks are bringing to the table?
Because the banks are forced intermediaries. You cannot do the transactions that I've described to you without the bank. In crypto, you can do all of your transactions without Anchorage. You can rebuild every single thing that we built simultaneously. Right now in the traditional financial system, you cannot replace the bank. They're there, period. Let me give you an example. When you have a credit card and you actually issue Diogo Monica, new credit card, black MX, really cool with like some NFT on it, golds, like I have this card. This card has a number. That number is called a BIN. That BIN needs something called a BIN sponsor. A BIN sponsor is basically a bank that has, because they're a bank, the right to issue numbers. That's literally what they do. They have the right to issue numbers, and so they sell this right to other people. Just like, why the fuck can I not just issue numbers? Like, Visa is the central controlling party. Why do I need the bank? Like, there's no reason why I need the bank to like hold the right to issue a number. That's literally called rent-seeking. That's rent-seeking. And we cannot go away from the system because the way that the system is set up and the rules of the system means that there's always a bank, there's always a BIN sponsor that always needs to be contacted and paid for them to borrow and allow you to actually issue this. On the blockchain, I go to the blockchain and I say, give me an address, and you generate a public-private key pair and you're off to the races. And so these two things are just fundamentally different. It's about you choose Anchorage because Anchorage can build more secure systems than you can to hold your Bitcoin, hold your Ethereum, stake it, buy and sell, settle, move stablecoins, on and on and on and on. You choose Anchorage because as a regulated institution, we're audited, and you want to trust somebody else. You are a company with 200 employees that are doing, I don't know, like CRM software. What do you know about private key custody? What do you know about security? Yep. Like, you should go trust the experts that have tens of billions, if not hundreds of billions on the platform. So you choose Anchorage because we're going to give you something of value, and we create something you can't do. No, you choose Anchorage because you must, because there's no other way of interacting with the system. So I want to make these things very clear. And yes, we're a bank, and yes, we make a lot of money, and I hope to make way more. Oh, we're
All right.
one more question. Go ahead, quick.
Yeah. So, do you think that quantum computing can be a threat for this transition that you dream and work on? So, are blockchains ready or will be ready for this future in technology?
So we have cryptographic mechanisms and signature schemes, et cetera, that are quantum safe. And so it's just a matter of doing transition. I think it's when the problem becomes acute enough, and in cryptography, we always see these things like, the heat is increasing. It increased on RSA, it increased on DSA. So all these things kind of like increase, like small slippages of bit security. And then at some point, it becomes critical enough for us to do transition. There is already quantum safe blockchains. And I think it's fine for us to kind of like parallelize blockchain safe and non-blockchain safe algorithms. And I think it's going to be fine for us to do the transition. So I don't see a major issue. Also, encryption is much more vulnerable than signatures in hashing functions. And blockchains primarily depend on hashing functions for historical integrity and depend on signatures for actually ownership. So candidly, I think it's fine. I don't want to ignore the problem because ignoring the problem creates the problem. But neither am I nervous. Quantum is going to remove all blockchain and eliminate all crypto. That's just not the case at all. That's never going to be the case. Well, thank you, everyone.
Yep.
Thank you for joining.
Thank you.